All right, we're going to talk about inequalities in this video. So inequalities are similar to something you've run into previously, namely an equation. Now an equation has the form A is equal to B, where what we are saying is that the expression A is equal to the expression B. You could write that out as a full sentence. When we talk about inequalities, we're talking about expressions where two things are not necessarily equal to each other. And there's a lot of different forms these can take. The simplest form is A is not equal to B. So when we write this down as a statement, we are saying A is not equal to B. And that's the basic form. It's basically saying not equals to. We could write something down like A is less than B. And what we mean is A is less than B. Sometimes we'll include a bar under this. And what we mean is that A is less than or equal to B. Okay? Likewise, if we flip this and we look at this statement, this is saying that if A is less than B, then B is bigger or greater than A. So what we do is we flip this little symbol to refer to greater than. So A is greater than B. And similarly, A is greater than or equal to B. So each of these are notations that refer to some ways in which two variables or two expressions can be different than one another, whether or not they're just exactly not equal to each other, maybe one is smaller than the other, or one is bigger than the other, or we also include the case where it's less than or equal to or greater than or equal to each other. All right, when we check these statements, we're asking if something is true. So for example, if I write down 2 is less than 3, this statement is true. And if we ask a question like x is less than or equal to 3, this is true if x is any number 3 or less. Okay? If I said, well, what happens if x is equal to 4 or x is equal to 5, this statement now becomes false. It's no longer true. Okay. So that's how we form our basic sentences that involve inequalities. Now let's talk about what we will be asking you to do when we run into different inequalities. So you might see a question that's of the form, solve x plus 1 over x minus 4 is less than or equal to 2. So this would be a problem statement that you would run into on a quiz or a worksheet or on an exam of some sort. Now, we want to be clear that this is clearly stating something that you need to do. It's telling you to solve, and then it gives you this statement, which is an inequality. Whenever you see the word solve, what we mean is that we want you to find all values of x which make this statement true. All right? So whenever you're asked to solve something like an equation or an inequality or anything of that sort, what it means is that in this expression we have x, and it's compiled in a somewhat complicated way. We have to add 1 to it, and then we also have to subtract 4 from it. We have to take the ratio of that, and then we're asking, is that less than or equal to 2? Now this ratio can come up from a variety of applications, but as mathematicians we're just worried about sort of the technique at this stage. And what we're saying is what x will work. So for example, you could try x is equal to, say, 1. And if we plug that into the expression, we get 1 plus 1 over 1 minus 4. Now, if we go ahead and calculate this, this is 2. 1 minus 4 is negative 3. So this is negative 2/3. And if I look at that, negative 2/3 is less than or equal to 2. And so this statement is true for x is equal to 1. Now simply finding x equal to 1 isn't the only solution. In fact, we can come up with other solutions. You could try different values right now, such as 0 or 5 or 10 or -5 or -10, and you'll be able to see whether or not it's true. And when we say solve, we mean to find all of them. So it's not just sufficient to find, say, 1. It might be also true for 1.1 and 1.01 and 1.000001 and so on and so forth. Likewise, it might also be true for pi and e and other various constants. And so when we solve, it's not just enough to find 1, we have to find all of them. So now that we have a sense for what it means to actually solve an inequality, let's talk about some of the steps and mechanics that we have to do in order to solve an inequality. Now, we can't simply just check every number. There's infinitely many numbers, and so that would take forever. And so algebra actually gives us some good methods to solve this quickly. So let's talk about some basic properties of inequalities that we can use to solve these equations. So as our inequality, we're going to suppose that A is less than B. Now all these properties work for any other choice of inequality symbol here. So if there's a greater than, a less than or equals to, or even a not equals to, all these properties still essentially hold. Now let's go ahead and let's just say the basics. First thing we could do is we can always add a value to both sides, and we can subtract a value from both sides. So if we think about this, if this statement is basically saying that A, will say, represents the amount of money in Aaron's pocket and B is the amount of money in Bob's pocket, then this sentence is saying that Aaron has less money in their pocket than Bob does. Okay? Now if we both give them the same amount of money, say some positive C, like $5 or $10, then the amount of money now in Aaron's pocket is still less than the amount of money in Bob's pocket because we've given them the same amount of money. Likewise, if we both ask them for a couple of dollars and we take that money away from them, then the amount of money that Aaron has after we've taken away those $2 is less than the amount of money that Bob has after we've taken away those $2. So this is how addition and subtraction works with all our inequalities. Now, if we want to multiply or divide, we actually have to be a little more careful. Now, let's go ahead and let's just look at the case that's simpler. So let's suppose that we have some multiplier amount, we'll call it D, and this is a positive number. Then if we look at the amount of money in Aaron's pocket and the amount of money in Bob's pocket, and we multiply that by the same amount, then the inequality is still preserved. In essence, if I double the amount of money in Aaron's pocket, and then I double the amount of money in Bob's pocket, the amount of money in Aaron's pocket is still less than the amount of money in Bob's pocket. And likewise, if I take a certain percentage of Aaron's money, and I take a certain percentage of Bob's money, Aaron will still have less money than Bob. Now the part where this gets tricky is the case where we actually multiply or divide by negative numbers. Okay? In the case where we multiply or divide by negative numbers, what happens is the inequality flips. Okay? And likewise, if we divide by that amount, the inequality flips as well. So another way to think about this is negative is reversing what's going on. So if I multiply by a negative number, it's turning them all into negative numbers. So let's look at a clean example to see why this property holds. So we can all agree that, say, for example, 2 is less than 3. That makes perfect sense, right? Now, if we were to add a number to both sides, this would still be true because we'd have 3 is less than 4. And likewise, if we were to multiply both sides by a positive number, say we were to multiply by 1/2, then what we would have is 2 times 1/2 is less than 3 times 1/2. And as you know, 2 over 2 is 1, that's less than 3/2, so on and so forth. Now what happens if we multiply by a negative number? So let's say we have 2 is less than 3, and we multiply both sides by -1. Well, on the left side, we get -2. And on the right side, we get -3. Now, if we look at this in terms of magnitude, -2 is actually sort of smaller than -3. But when we talk about the number line, we're talking about the ordered real line that starts from here and goes to here. And so, for example, we could put the center of the numbers here, and here we have 2, and here we have 3. So greater than means that you're further to the right, and less than means you're further to the left on the real line. So if we look at this, 2 less than 3 is the same as saying 2 is to the left of 3. Now if we compare -2 and -3, we take 2 steps over, that gives us -2, and then we take another step over, that gives us -3. And we'll notice that, in fact, -3 is now to the left of -2. And we write it down like this. Or if we want to flip the order, we can also write down that -3 is less than -2. Now, why does this happen? Well, when we multiply or divide reflects the number line. About 0. Look what happened. We started with 2 and 3 over here. We multiplied both of them by -1, and we noticed that they hopped over exactly across the line 0. And so 2 hops over to -2, and 3 hops over to -3. And so if you look at that, if inequality is making a statement about which one's to the right and which one's to the left, when we reflect, we'll notice that left becomes right and right becomes left. And so this is the tricky part when we solve inequalities, is noticing in these situations where the inequality flips from one way to the other.